Looking at the weather map right now, what we're seeing across North America is not a single storm system dominating the entire country. Instead, we have a multi-center atmospheric setup with three primary active zones, each doing its own thing in different parts of the continent. This is one of those patterns where different regions are experiencing completely different weather at the same time, and understanding which zone affects you is the key to knowing what to expect. So let's break this down piece by piece and talk about what's happening across North America. The big picture shows us three distinct areas of active weather. First, there's a Pacific frontal system impacting the western United States. Second, there's a northern snowbelt stretching all the way from the Rockies through the upper Midwest into the Great Lakes. And third, there's an offshore Atlantic low positioned east of the northeast coast. Between these three active zones, parts of the central United States remain comparatively quieter. So this isn't a coast-to-coast storm. This is a divided weather pattern with specific regions seeing specific impacts. Let's start with the northern snowbelt, because this is the main impact area for the United States right now. This snow zone is massive. It extends across Montana, Wyoming, North Dakota, South Dakota, northern Nebraska, Minnesota, Wisconsin, Michigan, and into northern portions of Illinois and possibly northern Indiana. This is a huge swath of territory, and it connects southward from southern Canada into the northern United States. So if you're anywhere in this zone, snow is the story. Why is the snow so widespread? The temperature map gives us the answer. A deep, cold air mass dominates the northern tier of the country. Surface temperatures are below freezing across much of this region, and that means any precipitation that falls is going to stay frozen. It's going to be snow. There's no question about precipitation type in this zone. The cold air is firmly entrenched, and it's not going anywhere quickly. This is the kind of setup where snow can accumulate steadily over time, and totals can add up, especially in areas where the snow bands are most persistent. Now, within this northern snowbelt, there's one area that deserves special attention, and that's the Great Lakes region. In northern Wisconsin, the upper peninsula of Michigan, and areas near Lake Superior and Lake Michigan, lake effect enhancement is possible. Here's how that works. When cold air moves over the relatively warmer waters of the Great Lakes, it picks up moisture. That moisture then gets dumped as snow on the downwind side of the lakes. Lake effect snow is often organized into narrow but very heavy bands. If you're under one of those bands, snow can pile up rapidly. We're talking about snowfall rates that can exceed an inch or two per hour in the most intense bands. And because these bands are narrow, you can have dramatically different conditions over short distances. One town might see 6 inches of snow, while a town 20 miles away sees a foot or more. Lake effect snow also reduces visibility significantly. When snow is falling that heavily, combined with wind, you can have near whiteout conditions. That makes road travel extremely hazardous. So if you're in the Great Lakes region, especially on the downwind side of the lakes, this is something to watch closely. Moving west, let's talk about the Rockies and the Mountain West, because there's another type of snow happening there. Snow is present across Idaho, Utah, Colorado, western Wyoming, and northern Nevada. This is orographic snow, which is a fancy way of saying mountain snow. Here's the mechanism. Moist air from the Pacific moves inland and encounters the mountain ranges. As that air is forced upward by the terrain, it cools, and the moisture condenses and falls as snow at higher elevations. This is why mountain passes can be treacherous even when lower valleys are relatively calm. Snow totals increase with elevation. If you're at 5,000 feet, you might see a few inches. If you're at 8 or 10,000 feet, you could see a foot or more. The impact here is mainly on travel. Mountain passes can become dangerous or even impassable. If you're planning to drive through the Rockies or the Sierra Nevada, check road conditions before you go. Chains or four-wheel drive might be required, and in some cases, passes might be closed altogether. Now let's shift to the Pacific Northwest, because that's where our second major system is active. Washington, Oregon, and Northern California are all being impacted by ongoing frontal rain. This is moisture flowing inland from the Pacific Ocean. The frontal structure is visible on satellite imagery, and it's bringing steady precipitation along the coast. At sea level and in the lower elevations, this is rain. It's not extreme, but it's persistent. In the Cascades and other higher elevations, this transitions to snow. So the pattern here is classic Pacific Northwest. Rain in Seattle and Portland, snow in the mountain passes. This is a typical Pacific system, and it's the kind of weather the region sees regularly during the winter months. The rain can be heavy at times, leading to localized flooding in areas with poor drainage. But overall, this is a manageable system for the Pacific Northwest. There's also a precipitation pocket in the southwest that's worth mentioning. Localized precipitation is showing up across Southern California, Southern Nevada, and possibly western Arizona. This appears to be separate from the northern snowbelt, which suggests a secondary disturbance or moisture surge in the region. This area may experience moderate rainfall with isolated heavier pockets. If you're in Los Angeles, Las Vegas, or Phoenix, keep an eye on the radar. Some of those heavier cells could produce brief periods of intense rain, and in desert areas, that can lead to flash flooding in washes and low-lying areas. Now let's talk about the central United States, because this is actually the quiet zone right now. States like Kansas, Oklahoma, central Texas, and southern Missouri are showing weaker precipitation signals and lower accumulation. This area is positioned between the northern snow system, the Pacific frontal system, and the offshore Atlantic system. It's basically in the calm zone between all the active weather. While it's not completely dry, impacts are much less intense compared to the northern tier or the coasts. If you're in the Central Plains, you're catching a break right now. Enjoy it, because patterns can shift, and what's quiet today might be active tomorrow. Out on the East Coast, there's an offshore Atlantic low that's worth discussing. Satellite imagery clearly shows a rotating low-pressure system east of the Carolinas, the Mid-Atlantic, and New England. This is a well-defined cyclonic system, and it's spinning out over the Atlantic Ocean. The key point here is that the majority of precipitation associated with this system remains offshore. It's over the water, not over land. If the system were to track closer to land, coastal areas could see rain or snow depending on temperature. But currently, the strongest impacts are over the Atlantic waters rather than inland. If you're along the coast in New England or the Mid-Atlantic, you might see some clouds and maybe some light precipitation, but the main action is staying offshore. This is something to monitor though, because if the track shifts westward, impacts could increase along the coast. Temperature is the key factor that's controlling all of this. So let's talk about the temperature gradient. The temperature map shows a strong north-south divide. In the cold sector, which includes the northern plains, the upper Midwest, the Great Lakes, and southern Canada, temperatures are well below freezing. In the transition zone, which runs through Iowa, northern Illinois, Indiana, and Ohio, temperatures are hovering around the freezing mark. And in the warm sector, which includes the southern United States, the Gulf Coast, Florida, and northern Mexico, temperatures are above freezing. This gradient controls precipitation type. North of the line, it's snow. South of the line, it's rain. Right along the line, you could see mixed precipitation. This boundary could shift slightly east or west depending on system movement. So if you're near the transition zone, small changes in the weather pattern could change what type of precipitation you see. Let's briefly touch on Canada and Mexico, because they're part of this continental picture. Southern Canada, including the Prairie Provinces and Ontario, is part of the same cold air mass that's feeding into the northern United States. Snow and cold conditions extend across the border, and the systems are dynamically connected. Canada is essentially the source region for the cold air that's driving the northern snowbelt. In Mexico, northern Mexico remains largely outside the major storm tracks. Warmer air is dominant there, and that's supporting the southern warm sector in the United States. Only localized precipitation appears near Baja California or in the northern Mexican highlands. So Canada is feeding the cold, Mexico is maintaining the warmth, and the United States is caught in between. Now let's summarize the primary risk areas, because I want to make sure you understand where the highest impacts are. The highest impact regions are the northern plains with widespread snow, the upper Midwest and Great Lakes with snow plus possible lake effect intensification, the Mountain West with elevation-based snowfall, the Pacific Northwest with persistent coastal rain and mountain snow, and Southern California and Nevada with localized moderate rainfall. The lower impact corridor is the Central Plains and portions of the southern Midwest, where conditions are relatively calm. So, putting it all together, the United States is currently experiencing a multi-system weather configuration. We have a cold-dominated northern snowbelt stretching from the Rockies all the way to the Great Lakes. We have Pacific moisture driving rain in the northwest and snow at higher elevations. We have a structured offshore Atlantic low spinning east of the northeast. We have a relative calm zone across parts of the central United States. And we have a strong temperature gradient controlling precipitation type across the country. The most significant weather impacts are concentrated in the northern tier states and near the Great Lakes, where snowfall and localized intensification are the primary concerns. If you're in the northern snow belt, prepare for winter travel conditions. Give yourself extra time. Make sure your vehicle is ready for snow and cold. And if you're in the Great Lakes region, be especially aware of lake effect snow potential. Those narrow bands can set up quickly and produce intense snowfall rates. If you're in the Pacific Northwest, you're dealing with persistent rain and mountain snow. This is typical winter weather for the region, but the persistence means it's going to stick around for a while. Make sure drainage systems are clear, and if you're traveling through mountain passes, check conditions before you go. If you're in the central United States, you're in the quiet zone. Conditions are relatively calm compared to the rest of the country. That doesn't mean you should let your guard down completely, because patterns can shift, but for now, you're not dealing with any major active weather. And if you're along the East Coast, keep an eye on that offshore system. Right now, it's staying over the water, but if it shifts westward, impacts could increase. Monitor updates if you're in coastal areas. The bottom line is this: North America is dealing with multiple weather systems at the same time, each affecting different regions. The northern tier is locked in snow and cold. The west coast has Pacific moisture. The east coast has an offshore system, and the center is relatively calm. Understanding which zone you're in is the key to knowing what to expect. This is a classic divided pattern, and it's going to persist for the next several days. Stay informed, be prepared, and know what's happening in your specific region.